Hello everyone. Today I am going to explain about how to calculate the factorial of number using 8051 microcontroller program with written in assembly language. So let's get started. Firstly, we have to load the inputs. For that, we have written move A60H. Here we loading the number n from the memory location 60h into the accumulator a. Then like that move r1 comma a, that copies the value into r1, which act as my loop counter. Okay, then r1 will be keep decreasing until it reaches to 0. Then we have to initialize the factorial result, that move a comma ash 1 h, that is the set of a equals to 1, because factorial process always starts with 1, means anything multiplied by the 1 doesn't change. So next we are moving to the main loop, that is multiplying the numbers. Here we first move the current counter value from r1 to register b. Then we use the instruction multiplication a into b with multiplies the a into b. Okay, then the result stays in A. So gradually becomes 1 into n into n minus 1, and n into n minus 1 into n minus 2, and it goes on until factorial is complete. So last, djnz r1 back means decrement r1 and just jump back to the label back until r1 becomes 0. This loop completes until the number from n down to 1 are multiplied. Okay, then we have to save that factorial result, right? So we return in assembly language like move 61h comma a, that will once the loop end, that results of the factorial will stores in the n and saved into the memory location 61h. And we are ending that program by returning sjmp dollars. This means infinite loop. The program stops here and useful for the simulations. Let's take the output. First we have to build the target and start debugging. When we start the debugging, it will shows the memory locations. In that memory location, firstly we have to 60h. On the memory address 60h we have to store 5, sorry, 4 is the memory. Then we have to save that and run the code. Then we will get the 18h as the output. This means it's a 24 decimal, but it shows 18h. That is our topic. Thank you. Next will be continued by Divya.
Hello everyone, I am Divya. Now I am going to explain about the greatest common divisor about this program in the assembly language. And now I have the load the inputs in the assembly level with the move A in the 62h. It is my first number, and then I am having the move B is 63h address, and it is a B second number. Then I am comparing the two numbers. It will give the CG and E, AB and continue, and SGMP done. This means if A not equal to B, it will go to the continue. If A is equal to B, it will show that GCD is found, and it will go to the done. Next I am continuing. I am checking which is the smaller, and it will carry the flag when a is less than b, and a is less than b means it is subtract a from b. Then a greater than b means it subtract b from the a. In next block I am going to check the a is less than b or not, and I am having here clear c. That means I reduce the larger number and it will repeat it. In case 2 I am going to check about the a less than b. It will save the a in R naught for temporarily, and it will compute the b minus a, but it is stored in a. Then I will restore that value in a. Now this loop will be repeat again. The it will found again it will found the GCD, and it will store the result at the GCD. If a equal to b, the value is the GCD. It will store the memory location in 64H, and this will loop and with the end. Now I am going to execution of this project. Now I will build target, and here we can see we have zero errors, zero warnings. Now I will next move on to the debugging. It will run with the code size limit 2k. And next I am giving the after this I am giving the input of my program 20 in 63 memory address, and I'm giving the our input another input 12 for the greatest integer for a and b values. I am entering the two values inputs, and next I am going to save this. And after the running the program, I am getting the GCD number. It will be a minus, and it will repeat, and it will check, and it will after the continuing the all the loop I have explained in the program. The memory stored in a 64H, the GCD number is 2. Thank you. Next will be continued by Jonathan. I will stop the debugging and my project.
Hello everyone, myself this is Jonathan H. Today I'm going to explain this program. In first we have org 000H. Org stands for origin. It tells the assembler to place the program starting from 0 memory location 000H. In third, in second we are going to move a comma 66H. MOV means data. MOV means move data. 66H is an internal RAM address where sensor 1 value is stored. This instruction loads the value from address 66H in this accumulator. The accumulator is the main register used for arithmetic and logical operations. In third, we are going to see XOR operation with sensor. In that, we are going to move XRL A, 67H. XRL stands for exclusive or logical operation. This instruction performs A equals XOR, value at address 67H. 67 holds the value of sensor 2. XOR compares each bit of both sensor values. Why XOR is useful means it detects differences between two sensors readings, error checking and encryption, and some checksum logics. In fourth, we are going to check the storing result. In that we are going to move 68H comma E. This stores the XOR output from the accumulator into memory location 68H. 68H acts as memory where the processed sensor value is saved. The stored result can be used later by display units, communication modules, and other system notifications. In sixth, we are going to SJMP dollars. SJMP means a short jump. Dollar represents a current instruction address. So the instruction makes the program jump to itself, forming an infinite loop. Thank you. Now I'm going to debug the code. Let's go to the execution part. Now I'm now I'll execute the program here. I'll give input as 55, 0, 55, 0 F. I've given input here. Now the Output will be shown here. See the output has been, wait a second, the output is low here. The output have been, shown here in the form of 5. So next part will be concluded by Durga.
Hello everyone, I am Durga. I'm going to explain fourth code. This program checks whether the number stored at RAM address 45H is even or odd. Then it writes the result to address 46H. The program starts at address 40H. This tells the 8051 where the program begins. And move A45H, the CPU reads the value stored at memory location 45H. The value is copied into a accumulator A. ANL A-01H, this performs A and 01H. This purpose extracts the LSB bit. LSB determines even or odd. LSB equal to 0 is even and 1 is odd. J is even, jump if the result is 0. If AND result is 0, jump is even label. If AND result not equal to 0, go to the next instruction is odd. If odd, branch to is odd. Move 46H #01H. It stores 01H at address 46H. This marks the number as odd. Is if even, jump to is even. Move 46H #00H. It stores the 00H at address 46H. This marks the number as even. Execution continues to done. Then program end. STMP done. CPU continuously jumps to the same address. Program halts execution used in simulators to the program stops. And we're going to debug the code by giving input 5 and output we get 01.
Thank you, everyone.
Let's end the meeting here.